This is called topic number 2, expansion, difficult level. So here, the first example, you can see that there are two brackets times each other. The first bracket, x plus 2 inside. And for the second bracket, which is x plus 3. So here, x plus 2 times x plus 3. So how to remove the bracket? To expand it, we also apply the rainbow method. So first of all, we take the first term in the first bracket and multiply all the terms in the second bracket. So x times x, this is the first step. X times positive 3, this is the second step. And then we take the second term in the first bracket times all the terms in the second bracket. So this positive 2 times x, this is the third step. Positive 2 times positive 3, this is the fourth step. So first of all, we write down the first step. X times x give us, so x power 1 times x power 1 give us x to the power 1 plus 1, which is x to the power 2. So therefore, for the first step, we have x power 2. And then for the second step, this is the first step, we get x squared. And for the second step, x times positive 3, which is positive 3x. Positive 3x. So this is the second step. And then the third step, positive 2 times x, which is positive 2x. This is the third step. And the last step, positive 2 times positive 3, which is positive 6. So this is the last step. Okay, after we remove all the brackets, then we need to consider there are 4 terms. Any terms are like terms. Obviously, x power 2 do not have any like terms, so we just copy it down, x power 2. And positive 3x plus 2x, they are like terms because they have the same unknown and the powers of the unknown are both equal to 1. So 3x plus 2x equal to 5x. 5x. So we combine these two. So we combine it and get positive 5x. And then we have another term, positive 6. So we just copy it down. Positive 6. So the final answer for this question, which is x squared plus 5x plus 6. This is the final answer. All the terms are unlike terms and they are arranged in descending order. Power 2, power 1, and constant. For the second example, we can use 2 ways to expand it. The first way, we keep using the rainbow method. So there are 2 terms in the first bracket and another 2 terms in the second bracket. So we can use the first term in the first bracket times all the terms in the second bracket, x times x, and x times negative 2. And we can also use the second term times all the terms in the second bracket, positive 2 times x, positive 2 times negative 2. So for the first step, x times x give us x squared. For the second step, this is the first step. For the second step, x times negative 2 give us negative 2x. This is the second step. The third step, positive 2 times x, which is positive 2x. this is the third step. And the fourth step, positive 2 times negative 2, which is negative 4. So this is the last step. Okay, among these 4 terms, obviously x squared, only one term, just copy it down. But the second term and the third terms, they are like terms. They both have x and the powers are both equal to 1. Negative 2x plus 2x. So just cancel each other. Add these 2 terms together, give you 0. So this is 0, negative 2x plus 2x. And then copy down minus 4. So this is the final answer. For this example, we can use alternate method because x plus 2 times x minus 2, which exactly the same as the formats of difference of 2 square. So a plus b times a minus b will give us a square minus b square. So difference of 2 squares, the identities of difference of 2 square. So we can apply the identity directly. So a plus b times a minus b. So a is x, b is 2. So we have a square minus b square. So a is x, so we write down x. B is 2, so we write down 2. So a is x squared minus 2 squared. So which give us x squared minus 4. Okay, so same answer with this one. They're same answer. Okay, that's it. Once we understand, we can apply the identity to help us to do expansion. So as you can see, the third example also in the same formats of the difference of 2 square. So you can see that here a plus b times a minus b. So we can apply the identity directly. So a square minus b square. So a is x, let me change the color, a square minus b square. Okay, so a is x, so I write x square. B is 5y, so I write 5y here, 5y square. Okay, x square, which equal to x square minus 5 square equal to 25, y square, which is y square. Okay, this is the final answer. That's it. For the fourth example, we cannot apply the same identity difference of 2 square. Here we need to understand this x plus 2y bracket to the power 2, which is the same format as the perfect square identity. So the perfect square's identity, which is a plus b bracket square equal to a square plus 2ab plus b square. So we need to apply this identity. So here, which is a square plus 2 times a times b plus b square. In this example, a is x, b is 2y. So we put it here, x squared plus 2x times 2y plus 2y squared. So which is x squared plus 2x times 2y, which is 4xy, plus 2y squared, which is 2 squared is 4, y squared is y squared. Okay, x squared plus 4xy plus 4y squared. These three terms are a 9 term. We cannot combine. So this is the final answer. For the fifth example, here we can use the negative perfect square, which is a minus b squared equal to a squared minus 2ab plus b squared. So for this question, also have a squared minus 2ab plus b squared. So in this question, a is 3x, b is 5y. So we just filled in a squared, which is 3x squared, and minus 2ab, a is 3x, b is 5y, so plus b squared, 5y squared. So here we get 3 squared, which is 9, x squared, which is x squared, minus 2 times 3x times 5y. 2 times 3 is 6, 6 times 5 is 30. So we also have times x times y, plus 5 squared, which is 25, y squared is y squared. Okay, y squared. So 9x squared minus 30xy plus 25y squared. No 9 terms here, so this is the final answer.